In the sub-zero death trap of Karelia, the greatest enemy wasn't the opposing army, it was the air itself. While a superior force froze solid in their tracks, the Finnish military used a simple piece of plywood to rewrite the rules of winter warfare. This is how improvised sledge logistics turned a primitive tool into a mobile survival engine. Welcome to the survival bunker, where we study the brutal reality of surviving war zones, sieges, and battlefield collapse. Today we are not examining a weapons system or a fortification. We are examining a sled, specifically the Finnish Ahkio, a low-profile plywood runner supply sledge that became one of the most decisive pieces of survival technology deployed in the Winter War of 1939. Not because it was sophisticated, but because it was precisely calibrated to an environment that destroyed everything that wasn't. This is the technical breakdown of how friction physics, thermal management, and mobile logistics turned the Karelian wilderness from a death trap into a weapon, and left 200,000 Red Army soldiers freezing inside it. The frozen stalemate of 1939. The Soviet Union invaded Finland on November 30th, 1939, deploying an estimated 450,000 troops across multiple axes, with mechanized armor, heavy artillery, and motorized supply columns. The strategic assumption was rapid collapse. Finland had a population of 3.7 million. The Red Army anticipated the campaign lasting weeks. What Soviet planners did not adequately account for was the meteorological reality of a Karelian winter arriving ahead of schedule. By mid-December 1939, temperatures across the Karelian Isthmus and the forests of eastern Finland had plunged to -40 degrees Celsius. The autumn mud that had already begun slowing Soviet motorized columns froze solid overnight, but that transition brought no relief. At -40, diesel fuel gels in unheated tanks, engine blocks crack without continuous warming. Tracked vehicles that had struggled through mud now required fires lit beneath them every few hours simply to start. The Red Army's motorized divisions were road-bound by design. Soviet military doctrine in 1939 was built around mechanized combined arms warfare. Armor and motorized infantry supported by truck-borne supply columns moving on established roads. In Karelia, roads were sparse, narrow, and surrounded by dense boreal forest. The moment Soviet columns left the road network, they stopped moving. And on the roads, they were channeled into predictable linear formations that the Finnish defenders could identify, isolate, and attack at will. The physiological damage began almost immediately. Red Army soldiers issued standard Soviet winter kit, which was insufficient for sustained static exposure at these temperatures, began developing trench foot and frostbite within hours of halting in place. Medical records from the conflict document frostbite casualties numbering in the tens of thousands before the campaign's first month was complete. Frostbite follows a precise clinical progression: vasoconstriction in the extremities, loss of sensation, ice crystal formation in tissue fluid, and permanent cellular destruction if the affected area is not warmed within a critical window. A soldier with frostbitten feet cannot patrol. A soldier with frostbitten hands cannot operate a weapon. The Red Army was being removed from combat effectiveness, not by Finnish bullets, but by ambient temperature. The Finnish army faced identical temperatures. Their survival required a completely different approach to logistics and frontline thermal management, one that did not depend on roads, engines, or static heated positions. The physics of the plywood runner is, well, pretty fascinating. The Ahkio wasn't actually invented for the Winter War. In fact, it was a traditional Finnish and Sami utility sledge used for hauling supplies and game across snowy terrain for, honestly, centuries. What the Finnish military did back in 1939 was to systematically engineer and mass-produce a specific variant, one that was optimized for frontline logistics in the Karelian forest environment. The core engineering insight here was really all about ground pressure and friction management. You see, a fully loaded Soviet supply truck exerts ground pressure measured in kilograms per square centimeter, enough actually to punch right through the snow crust and get bogged down in soft snow within just a few meters of leaving a compacted road surface. The Archeo, when fully loaded, distributed its weight across two long, narrow runners, each in contact with the snow along their entire length. The resulting ground pressure was, well, negligible. The sledge just rode on top of snow surfaces that would absolutely swallow a vehicle. The runner material was honestly absolutely critical. Finnish craftsmen used birch and pine plywood, carefully selected for specific grain orientation, with the long grain running parallel to the direction of travel. This orientation takes advantage of the anisotropic friction properties of wood. Resistance to lateral movement is high, but resistance to forward sliding along the grain is dramatically lower than cross grain, which is kind of brilliant. The runners were further treated with water, applied in controlled thin layers that then froze to form a thin ice surface coating on the wood, a technique drawn directly from traditional Scandinavian sledge preparation. Ice on ice, in fact, has a coefficient of kinetic friction as low as 0.03. That's actually lower than most engineered bearing surfaces, so a well-prepared Archeo runner on packed snow required only minimal pull force to keep it moving. The low-profile design served a second function beyond mobility. The Archeo's silhouette was actually below the height of standard forest undergrowth. Finnish ski troops could haul supply sledges through forested terrain where, honestly, no vehicle could physically operate, following routes between trees that were completely invisible to Soviet aerial and ground observation. The supply line had no visible road signature, no engine noise, and no exhaust, 3 of the 4 primary indicators Soviet scouts would have used to locate Finnish logistics activity. Thermal management and mobile heat stations. The Archeo's role in the Finnish survival system extended beyond supply transport. Modified versions of the Sledge were configured as mobile thermal management platforms, field-expedient heat stations that could be moved with the front line rather than anchored to permanent barracks. The construction was specific. The cargo well of the modified Sledge was lined with insulating birch bark layers underneath a sand and gravel thermal mass. On top of this base, a contained charcoal or wood coal fire could be maintained during movement, using a shielded metal firebox design that prevented flame extinction from wind or movement. The thermal mass absorbed heat and released it slowly. A low-tech heat storage system that maintained effective warmth for several hours after the fire was reduced or extinguished for stealth. The tactical application addressed the central problem of winter frontline survival, maintaining core body temperature without permanent heated infrastructure. Finnish soldiers operating deep in the Karelian forest, simply could not return to heated barracks after each patrol. The distance from forward positions to rear installations was just too great, and movement was far too slow on skis in that dense forest. So, the mobile heat station allowed a unit of 4 to 6 men to, carry their thermal recovery capability with them. The rotation system used alongside these sledges was tactically precise. Finnish commanders quite cleverly implemented structured exertion rotations right at the front line. Soldiers assigned to haul sledges through the forest. They generated significant metabolic heat through the physical work, maintaining core body temperature through movement rather than, relying on external heat. When those soldiers reached a forward position, they switched to static defensive or observation roles, while the previously static soldiers took over the haul duties. The physical work of moving the sledge was not a logistical burden at all. It was, in fact, deliberate thermal management built directly into the operational schedule. This system allowed Finnish units to maintain offensive operational pressure for multiple consecutive days without returning to permanent heated positions, a capability the Red Army, tethered as it was to vehicle-dependent supply lines and static campfires, simply could not replicate. Strategic encirclement through superior glide. That's really what set the Finnish approach apart. You see, the mobility advantage conferred by the Akio system was the operational foundation of the Finnish Motti tactic, which was all about the systematic encirclement and isolation of Soviet columns. Now, Motti is actually a Finnish unit of measurement for a cubic meter of firewood, a deliberate reference, if you will, to the idea of cutting an enemy force into isolated, manageable pieces. The tactic worked because Finnish ski and sledge units could move through forest terrain at speeds and along routes that Soviet motorized units simply could not match or follow. So, Finnish units would identify a Soviet column advancing along a road, move through the forest parallel to the column using terrain invisible to Soviet scouts, and advance ahead of the column to establish blocking positions across the road before the Soviets arrived. The same mobility was then used to establish a second blocking position behind the column, completing the encirclement. The critical variable here was supply line interdiction. Once encircled, a Soviet motorized column required continuous fuel, food, and ammunition delivery by road to sustain operations. The Finnish blocking positions, though, eliminated that delivery. Soviet units inside a Motti pocket could not move their vehicles off the road to break out, could not receive resupply, and were burning fuel to keep engines and fires running, which in turn accelerated their consumption of the supplies they already had. Finnish Akio-borne logistics chains, meanwhile, kept the encircling units continuously supplied through the forest. An isolated Finnish platoon holding a blocking position on a Karelian forest road could receive ammunition, food, and medical evacuation capability via Sledge through routes the surrounded Soviet forces could not identify or interdict. The psychological dimension was documented in Soviet after-action records and prisoner accounts. Red Army soldiers reported that Finnish forces appeared to suffer no cold, no fatigue, and no supply shortages, materializing from the forest to attack and vanishing back into it without apparent logistical need. The reality was a precisely engineered light logistics system that synchronized with the environment rather than fighting it. Modern applications of primitive thermal logic. The engineering principles validated in Karelia in 1939 did not remain historical curiosities. They propagated directly into high-latitude military doctrine and polar expedition technology that remains in operational use in 2026. NATO cold-weather warfare doctrine, particularly as developed through Norwegian and Finnish military training programs, retains the Akio Sledge as standard equipment for Arctic infantry units. The Norwegian Army's current Akio variant is constructed from modern composite materials, but, it preserves the original runner geometry and ground pressure principles unchanged. The physics have not been improved upon because, the original design was already optimal for its environment. Modern ultralight polar expedition sleds used in Antarctic traverses and Arctic research deployments are direct engineering descendants of the Karelian sledge. The runner profiles, load distribution, geometry, and material selection in contemporary polar sleds reference the same friction and ground pressure principles Finnish craftsmen applied in 1939. The progression from birch plywood to UHMWPE runner material is a materials substitution, not an engineering revision. The broader lesson that cold weather survival specialists consistently extract from the winter war experience is really the primacy of environmental synchronization over technological complexity. Battery-dependent heating systems fail at -40. Electronically managed Vehicle systems fail at -40. GPS and radio equipment requires heated storage and operation protocols at -40. The Accio required none of those accommodations. It functioned at -40 because it was built from materials that perform better in cold than in warmth. Wood hardens at low temperatures. Ice friction decreases with decreasing temperature down to approximately -20. And the absence of mechanical or electronic components meant the absence of mechanical or electronic failure modes. The Winter War ended on March 13, 1940, with the Moscow Peace Treaty. Finland ceded approximately 11% of its territory, including the Karelian Isthmus. The Red Army, despite overwhelming numerical superiority, had suffered estimated casualties of 125,000 to 170,000 killed, against Finnish losses of approximately 25,000. The casualty disparity was not explained entirely by Finnish marksmanship or terrain familiarity. A substantial portion of it was explained by the fact that Finnish soldiers were warm, mobile, and supplied, while their opponents were progressively immobilized by the environment they could not synchronize with. A plywood runner on crystalline snow, prepared with a thin coat of ice, carried that advantage from the forest to the outcome of the campaign. The Finnish army entered the Winter War as a 300,000-man force opposing a military that outnumbered it by more than 4-1. It did not survive that war through firepower. It survived through environmental intelligence, through understanding the physics of cold so precisely that the cold became an asset rather than a liability. The Accio was not a survival solution. It was the physical expression of that understanding, built from wood, shaped by physics, and pulled through a forest that swallowed everything that wasn't designed to move through it. If this briefing changed the way you think about what survival technology actually means, subscribe to the Survival Bunker and share this video. Every share puts this research in front of someone who takes history and preparedness seriously. Hit the notification bell and we will see you at the next briefing.